have all the way from Pittsburgh, our industry spokesperson, Mr. Ken Komoroski, and he works for Cabot. And if I could, he has represented Cabot Oil for more than 20 years. He is a partner with a law firm in Pittsburgh, K&L Gates. He has active practices in field of oil and gas law and environmental law. In addition to representing Cabot, Mr. Komoroski represents several independent producers of natural gas and oil. Prior to beginning his law practice, Ken was an environmental engineer and supervisor for a chemical manufacturing company. He received his BS in environmental engineering from Penn State, waste, water, and water treatment specialization. Please welcome Mr. Komoroski.
Thank you very much. Thank you for all attending tonight, and thank you especially to the League of Women Voters for hosting this event. I've got about 15 minutes is what they give me to speak, and there will be question and answers later, so I'll move through relatively quickly, of course. And I'm going to talk generally about the water quality protection measures in the industry, and I'll also spend a few minutes at the end just giving you a very brief update on the situation in Dimock as we see it. And what I'd ask you, I think the most important thing is that everyone forms their opinions based on the information they have available to them. And so the more information you have, the better able everyone is to make reach their own opinions and conclusions. And we think the League of Women Voters does a great job putting forums like this together to help present a balanced piece. So with that, I'll say too, and maybe this would be a question I get in any event, but I'll answer it just on the possibility that I will. Cabot's position is that as we are in favor of public disclosure of additives to frac fluids. We think that's a good idea. And we're also in favor of EPA study of hydraulic fracturing, and any potential impacts on water supplies. We think those are both good ideas. Okay, so this is the overview of my presentation for this evening. We're here to talk about our water resources, and this is a state that's blessed with abundant water resources, great water resources, important for drinking and many other purposes. So, and obviously that includes not just surface water, rivers and streams, but groundwater as well. So the water uses for the Marcellus Shale development are drilling and hydraulic fracturing. Yes, some water is used to create the mud that's used to drill the well. That's a relatively small amount, and a relatively larger amount is used for hydraulic fracturing. And I'll get into that in a little more detail in a moment. And an important topic here, of course, is the flowback water. After you fracture the well, then after you fracture the formation, some amount of water flows back, and that the basic options for that are to reuse it or to treat it and dispose of it. Okay, you've probably seen slides like this a lot of times, and we're focusing more on the water quality aspect of it, but just to show the geographic reach of the Marcellus Shale and how many counties and how many people are involved in and are affected and will be affected by this development as it goes forward. So it's very extensive, very large. It's the largest shale play in the country area-wise. And just a few days ago, I was approached because the oil minister from Qatar, Qatar has the largest natural gas field in the world, wants to come to Pennsylvania and meet to discuss the Marcellus Shale because this is the second largest natural gas field in the world. All right, one thing, again, I talked to a lot of people. I've spoken with a lot of folks who live here in Dimock, and I've spoken to a lot of media representatives. And one of the things that I think is not well understood, and if you've got it down, great, and I'll bore you with the next part, but if not, there are 4 phases of development when you're going to produce gas. The first is site construction, and that is construction. I mean, it's bulldozers and backhoes and leveling out an area, 5, 6, 7 acre pad, putting rock on it. There's nothing that's specific to oil and gas activity at that point. So that first phase is site construction. And each of these phases, it's important because in respect of what controls need to be in place in order to protect the water. Second is the drilling of the well, and that after some period of time, it could be the next day, it could be a month later, it could be 2 years later, you bring the drilling rig in to drill the well. And that's the part where you use maybe thousands of gallons of water if you're drilling with mud. You can drill on air to drill the well. That mud then ends up in a pit and is either remains on site or is hauled off site. The third phase is well completion. Now that's the term the industry uses, but that's the part where hydraulic fracturing occurs. And that's where, and I'll talk about this more again specifically, greater volumes of water are used. And the fourth is the production phase. And that's, the site construction takes a week or two. Drilling takes 30 days, 30 to 40 days. Well completion, actually, depending on how many stages, that could be done in 48 hours, 72 hours. Per well. And then production is what occurs for decades. And so after all the initial activity, what you'll see for 40, 50, 60, 70 years is the wellhead, a few tanks, and some metering equipment on the location. And that has a much, much smaller footprint. So the measures that are in place to take care of the water quality, to protect the water quality, are erosion and sedimentation control. And that, in the construction phase, that's just critical. That's when you're turning dirt, you've got to make sure the measures are in place. Stormwater management, that's really the same issue for us. Although we have to make sure too that there isn't an increased flow that comes from our locations that causes problems for the folks downhill. Preparedness, prevention, and contingency plans. Now that's a program that's been in place for a long time, administered by the DEP. But that is what is used to make sure that we look at what materials we use on location for construction, drilling, fracturing, and make sure that we have measures in place to prevent those from entering the environment. And finally is site restoration, and that's a very important one because once we go to the production phase, then, and we're required by law to recover the site, to reclaim it, seed it, mulch and seed it, grow grass, restore vegetation, and all of that is works effectively then, so that there really is, at that point, once the site is properly reclaimed, no opportunity for pollution, any water contamination from a well. Okay, now, these aren't the best pictures, but they are pictures, and they're not to say that that's the same location, but just fundamentally, the active drilling is a drill rig, and they come in different sizes. The pads can be much, much larger than that. That, I don't know how large that one is, but one of the things that the industry is trying to do, and Cabot is trying to do, is to drill as many wells from a single pad, use horizontal drilling, and so you use a larger pad for that. Now, the bad news is you'll use a larger pad for that. The good news is that a single pad can eliminate the need for 45 different surface locations. So we think that's a good thing. Following restoration, and look, it's got the pretty lavender flowers in the front, but that's not the point. The point is that the ultimate footprint, what you will see, what you will live with as residents in this area, is going to look like that. Now, if it's a pad that has multiple wells, it's going to have more than that. That in the foreground of the pad itself, there would be more than that, and the pad area could be larger. So I'm not saying that's as small as they typically are. That's just the picture I had available. But the point is, again, that most of the disruption and what happens to the roads, especially this time of year, I mean, it's a disruptive practice. It is. But at the end of it, this is what we live with for a much longer period of time. Okay, water use. Pulling the water out of the streams and using it for hydraulic fracturing. That's administered by the Pennsylvania DEP. You have to submit a water management plan to the DEP and have that approved. And all drilling has to be done in accordance with an approved water management plan. And the application form is 4 or 5 pages, quite a bit of information. It's all designed to make sure that the withdrawal of water does not have an adverse effect on the stream from which it's withdrawn. Also, depending on where you're located, and of course in this area, the Susquehanna River Basin, is the Susquehanna River Basin Commission has a very extensive approval process, and if you're east of here, Delaware River Basin Commission has the approval process. Okay, so, and this is the activity that I want to talk the most about, and the last bullet item, probably evokes some response, but that's scientifically correct. And that's not a surprise. That's not an accident that there haven't been documented cases. What we focus on is the surface spills, the surface issues. That's where we have the potential to adversely affect water supplies. That's where we have to be the most careful. The hydraulic fracturing, again, we're in support of the disclosure of what the additives are, but they don't get into the water because there's really, scientifically, it's somewhere between awfully darn hard to impossible for that to occur. But there is the potential during drilling, during site construction, during trucks moving in and out. I mean, there have been diesel spills, and there have been recently been diesel spills, and that's from the equipment itself. The activities on the surface are where we focus our energies, where we're not perfect, where we work hard, but that is where we have the potential to affect water supplies. Hydraulic fracturing simply does not have that potential. So and that's because of the design of the system and the fact that well, look, I mean, whether you call them additives or chemicals, they're the least important part of the process to us. The volume of water and using 10,000 pounds of pressure to crack open that rock 6,000 or 7,000 or 8,000 feet deep, that's what we need. And then we need the sand to hold open the cracks. And these other elements of it help to keep the sand suspended, help to reduce friction, help to avoid bacterial growth in the well, things that can adversely affect performance. But that's just not the big part of it. So in the industry, I mean, we simply can move more and more in a green direction. We don't have to use things like petroleum distillates. We don't have to use things like that. So we can continue to move in that direction. Cabot is moving in that direction. And I'll come back to this later if I have time, but the other thing is that at present, Cabot is reusing 100% of the water that flows back from the wells. That has not been the case initially, that is the case now. Okay, now this isn't to scale, and I still haven't found one that is to scale. Maybe it's because there isn't one that fits on a screen or you can't see anything, but the important point here is that the thicker blue line, at the top, well, the freshwater supplies are maybe at most 500 or 600 or 700 feet deep. Where we're fracturing the Marcellus is 7,000 feet deep. So the injection of those additives in that water and that sand is so far below freshwater supplies, it is impossible for that to affect water supplies. Now, again, if you spill it on the surface, yes, it can. If there was a problem with the several series of casings and steel casings and cementing at the surface, yes, it can. But it hasn't in tens of thousands of opportunities to do so. And as at least a former engineer, that tells me a great deal. So again, disclosure of that and study of that is only going to help reinforce that that's not where the issue is. The issue we have to focus is on surface activities. Right, and this is a bit more about the protection of water supplies. Now this goes more towards the drilling and the casing and cementing standards, and these are DEP standards. These are requirements for anyone who drills wells. And again, if we had more time, we could go through them. I've seen some great where you actually have the pieces of casing and cement to show the levels of protection that exist in the well. It's absolutely in your interest for us to protect water supplies. It's in our interest to protect water supplies too. It's not a good thing when water supplies are adversely affected. All right, flowback water. Let's talk about the volumes. And again, you form impressions based on the amount of water. Given the number of stages in a horizontal well, and one of the things from that earlier picture, this is what would be called a 6-stage well, because there's 6 points along that horizontal lateral where you're going to do fracking, and you do each one in succession. 1 stop, 2 stop, 3 stop. So, but if you're going to do a 6-stage well, you're going to use 3 to 4 million gallons total for hydraulic fracturing, about 600,000 gallons per stage. And actually less water is flowing back from the Marcellus than has been flowing back from conventional well drilling in Pennsylvania, considerably less. So that's less water to have to deal with, and that's actually made total reuse an opportunity in many, many parts of the state. Most importantly, no, not most importantly, but another important element is the contents of flowback. It's heavily, heavily salt laden. Geologically, this gas comes from receding oceans. So these were formerly oceans, and that Marcellus Shale is decayed biota from an ocean that existed here, I don't know how long ago, but the salt and the minerals and the gas, which is the decomposed organic matter, is what the Marcellus Shale is. Now, there is, in addition, whatever additives that we've put in, but at that point, now it's diluted even further, but that comes back up the pipe. That never enters the water supply unless we spill it on the surface. If we're putting it into a truck to haul it to the next location, or in a pipe, pumping it to the next location to frack the next well, and we spill it, that can affect water supplies. That's what we have to avoid. That's what we have to concentrate our efforts on. Okay, as I said, options for hydraulic fracturing water is we can blend it with fresh water. We can take that flowback water because the volumes are small enough and we have enough new activity going on that we can blend it up and continue to use it for hydraulic fracturing. You can treat it, and in theory you can dispose of it by underground injection. There isn't a great deal of capacity in Pennsylvania, geologically speaking, for that last option, so it isn't used to a great extent. Okay, so in summary, protection of water resources, surface and groundwater. First of all, prudent use of water supplies. We have to make sure we're pulling from a stream that can handle it. The Susquehanna River itself, we talked about using 3 or 4 gallons. The Susquehanna River flows south of here, down in the Harrisburg area, 19 million gallons per minute. So, and this time of year, and with what you can see in the streams around here from the snow melt, pulling water out of a stream would actually be a good thing. In the summertime, we have to be much more careful and actually have to avoid, where we can, pulling from small streams. Next, prevention of surface spills. That again, I said it probably 4 times already.